Hello friends. So finding critical path from all the possible paths will not be that much difficult if the number of nodes are less than 6 or 7 or 8 max. But if the number of nodes or number of activities are more than that, maybe 10 or 20 or 30, which will be true for the real practical cases of projects, then finding all the paths and calculating the total time taken for each path will be a tedious task. So people have come up with another method to find out or how to get the critical path. So for that, we need to understand certain terminologies. So two of them is the earliest start and earliest finish time. So earliest start is nothing but how early an activity can be started. Now, if the activity is starting at its earliest time, so what could be the earliest finish time? So the earliest start time plus the duration of the activity will give you the earliest finish time. So it's very simple. So these are two things. So to understand with an example, suppose take the case of this activity A having a duration of 5. The starting node is 1 and ending node is 2. So for all the starting nodes, the earliest start time is 0. If it's for the case of the starting node, if I'm saying not the middle nodes, I'm only saying the initial starting nodes. So which means that I can start only at the 0th time. So after just I start, the time is going and it's not the so earliest I can start is the 0th time, and plus duration will give you the earliest finish time. So for this case, the earliest start time will be 0 and the earliest finish time will be 5. That's all. And also one thing to be noted is that we are going forward. So earliest start times are calculated based on the forward pass. So when we do the examples, I will explain what is a forward pass and backward pass. So just to understand, give you a glimpse. So we are moving forward. So earliest start time will depend on the previous activity. If it's a middle node or a middle activity, so what early the other activity ends. So that will give you the earliest start time for the current activity. Okay. Similar to earliest start and finish time, there are latest start time and finish time. So this is calculated through backward passing calculation. So which means that the latest start and finish time will depend on the next activity, the next activity which is going to come, the successor activity. So latest start time is the how late the activity can be started, and latest finish time will be how late the activity has to be finished. So it is coming from the backward. So you can see that if you have latest finishing time, suppose for this case, for the node for the activity P, if 26 is the latest finish time of this activity, then latest start time will be 26 minus 2 will give you 24. So that is the latest start time for this. So this is very simple, and with the more examples we will learn what it is. Another important term to understand is slack or float or free time. So this is how the activity, how much activity can be delayed without affecting the total completion time of the project. Okay, let's understand it with an example. Suppose we have C. C is the activity, and the earliest start time for C is 5. So we can start early at the 5th week. If I am starting at the 5th week, the duration is 4, so I can finish it in the 9th week. So that is the earliest finishing time, right? Now, what is the latest? By latest, I have to start is 8th week. I cannot go beyond that. So that is my deadline. I have to start. I must start the 8th week because the latest finishing time, the deadline for this could be the 12th week. Okay. So if I start at the 5th week, I will complete at the 9th week. If I start at the 6th week, I can complete it by the 10th week. So the latest I can start is, latest I have to finish is 12th week. So the latest I have to start is 8th week. Now you might understand what is earliest start time and earliest finish time, right? The slack means this, what is the window that I can play with, so that my entire project completion time will not be affected. Okay. So that window is known as slack or float or free time. So how can we calculate this? It's just a difference between the finishing times or the difference between the starting times, or earliest finish minus earliest latest finish minus earliest finish, or latest start minus earliest start. Or the most convenient formula will be earliest finish minus earliest start, latest finish minus earliest start minus t. So this is my latest finishing time, 12. So these are the earliest start and finishing time. In the bottom, it's latest start and finishing time. So this is the latest finishing time, 12, minus earliest start time is 5, minus the duration is 4, which will give you the answer 3. So we will use this formula to calculate. To understand float, it is just the suppose there are many activities where the maximum time is more than that of the time required to complete the activity. So that window is more than which is required for it. Okay. So that difference is known as float, simply. So there are many kind of floats. So mainly there are 3. We will learn one more in the when we do the examples. So the total float is happening when all the preceding activities happens at the earliest possible times, and all the succeeding activities occur at the latest times. So it is just the ls minus es or lf minus ef, as we have already seen. Second is the free float. Free float is nothing but total float minus head events, or the time available when all the preceding activities occur at the earliest possible time, and all the succeeding activities also occur at the earliest possible times. So if you know the total float, you can subtract the head event slack. So the difference in that head event, we will learn what is head event slack. The difference will give you the free float. Similarly, independent float means it can be defined as the amount of time by which the start of an activity can be delayed without affecting the earliest time of any of the successor activity, which assumes that the preceding activity has finished at its latest finishing time. So independent slack is nothing but free float minus the tail event slack. So to solve a classroom kind of problem for the network which is given here, we will learn how to find out all the critical path, the length of critical path, and all the floats. So basically, we have 4 sets of values, like earliest start, earliest finish, latest start, and latest finish. But for in a gate exam, if you go and calculate all the 4 things and find out the various things, will be very hectic for you, and it will consume a lot of time. So the easiest way is you will restrict only to 2. So we will find out only the earliest start time and the earliest finish time. Now coming to for the first activity, the earliest starting time will be 0. So that we have already seen with an example. So earliest start time, I will give it to S0. So the green boxes will represent the I will put the earliest start times, and the blue boxes or the gray boxes I will put the latest finishing time. So suppose if I get for 1, the node 1 earliest start time will be 0, and for node 2 it will be 0 plus 4, it will be 4. Now for 3, 0 plus 3 will give you 3. Now for 4 it will be the node 4, it will be 4 plus 2 will give you 6. Now for node 5, there are 2 ways. Either it will be 4 plus 7, which will give you 11. Otherwise 3, this 3 plus 6, which will give you 9. So we will take the maximum out of it. So it will be 4 plus 7, which will be 11. Just focus and just understand. So if you have 2 or more ways, then the maximum has to be taken in the forward passing. We are doing the forward passing. Now for 6, there are 2 ways. Either it will be 11 plus 2, which will be 13, or 6 plus 4 will be 10. So what is maximum? So 13 is maximum. So I will put 13. So for the last node, the latest time means earliest finish time and the latest finish time will be the same. So I can put 13 here. So whatever comes here, it is 13 here. So now I'll do the backward passing. So backward passing means now this is the latest finishing time for the event 6. Now for event 4, it will be 13 minus 4 will give you 9. Here 13 minus 2 will give you 11. For this 2, it will be 9 minus 2, 7, or 11 minus 7, 4. So in the backward passing, we will take the least one, the minimum one. So it will be 11 minus 7, which will be 4. Now for this one, it will be 11 minus 6, which will be 5. And here it will be 5 minus 3 is 2, or 4 minus 4 is 0. So it will be 0. So for this node also, the upper and lower part will be the same, and for this thing also. Now whatever coming in this box will be the length of your critical path. Now so this is forward passing and backward passing, so we can fill all the important things with this thing. So first we will fill the earliest starting time and see how to do that. It is very simple. Earliest start time means for 1, 2, this node, this activity, what is the earliest starting time is the for the starting node, so that is 0. So for earliest starting time will be 0. And for 1, 3 also, since 1 is the starting event, the earliest start time is for 1 is 0. Now 2, 4, the earliest start time will be 4. 2, 5 also, it will be 4 because 2 is the starting event. Now 3, 5, so for that that will be 3. 3 is the, and for 4, 6, 4 is the starting node and the value will be 6. And for 5, 6, 5 is the starting node, so it will be 11. Now what is the latest finishing time? Latest finishing time also we can get it from here. So latest finishing time is this, the top one in the gray. So latest finishing time will be, this is for 13. Now for 4, so now 4, 6, it will be the same, but because 6 is the ending node, so latest finishing time is for the ending node or the finishing node. 3, 5, 5 is the finishing node, so that will be 11. For 2, 5, so 5 is the finishing node, so it will be the same, 11. For 2, 4, it will be 9, because for 4, in 2, 4, 4 is the finishing event, so latest finishing time will be 9. And for 1, 3, 3 is the finishing event, so what is that? It is 5. And for 1, 2, it will be 4. So that's how we calculate the earliest starting time. So there is no need for finding the EF, or earliest finishing time, or latest start time. We will fill up other this thing, because that will be sufficient to find out the slacks and all. Now the head event slack means, suppose if it is 1, 2 is the event, so the head event will be 2. So slack will be this 4 minus 4, right? For this node, so suppose for this one, the head event will be 5, and for head event slack will be 11 minus 11 will be 0. So that's how we find the head event slack. Now, so 1 to 2, 2 is the head event, and 4 minus 4 will be. Now 1 to 3, 3 is the head event. For the 3 head event slack will be 5 minus 3 will be 2. For 2 to 4, 4 is the head event. So for 4, 9 minus 6 will be 3. For 2 to 5, 5 is the head event. So 11 minus 11 will be 0. So 3 to 5 will also be, since 5 is the head event, that will also be 0. 4 to 6, 6 is the head event, that will be 0, because 13 minus 13. For 5 to 6 also, 13 minus 13 will be 0, because 6 is the head event. Now for the tail event slack, so for 1 to 2, 1 is the tail event. the slack for 1 will be 0 minus 0 will be 0. 1 to 3, same. 1 is the tail event. So the tail event slack will be 0 minus 0 equal to 0. Then 2 to 4, 2 is the tail event. So 4 minus 4 will be 0. So 2 to 5, 2 is the tail event. So it will be 0. 3 to 5, 3 is the tail event. So for 3, 5 minus 3 will be 2. And 4 to 6, 4 is the tail event. And 9 minus 6 will be 3. And 5 to 6, 5 is the tail event. And 11 minus 11 will be 0. Now, total float. Here we have an equation. Total float is LF minus ES of minus T. So LF is here, ES is here, minus T. That will give you the total float. So for the 1 to 2, so 4 minus 0 minus 4 will be 0. So 1 to 3, it will be 5 minus 0 minus 3 will be 2. For 2 to 4, 9 minus 4 minus 2 will be give you 3. Here 11 minus 4 minus 7 will give you 0. Here 11 minus 3 minus 6 will give you 2. Here 13 minus 6 minus 4 will give you 3. Here 13 minus 11 minus 2 will give you 0. So this is the total float. Now calculating free float, the equation is total float minus head event slack. Okay. So this column minus this column. So how it will be? 0 minus 0 0, 2 minus 2 0, 3 minus 3 0, 0 minus 0, 2 minus 0 2, 3 minus 0 3, and 0 minus 0 0. Very simple. Independent float is nothing but free float minus the tail event slack. So this column minus this column. So how much it will be? 0 minus 0 0, 0 minus 0 0, again 0 minus 0 0, 0 minus 0 0, 2 minus 2 0, 3 minus 3 0, 0 minus 0 0. So this is how you calculate the one important thing that we have to learn is what is the critical path here. How we can find out the critical path using the slack. So we can find the critical path using the total float or total slack. So for all the events in the critical path, the slack will be 0. So and total slack and free float, total float and free float will be 0. So you can find out that what are the activities where total float and free float is 0. So that will give you the critical path. So for here you can see that. So this is the total float. This is the free float. So this is 0. Okay. Now this is not 0. This is not 0. This is 0. Now this is not 0. This is not 0. This is 0. So these three activities conclude the critical path. Now we can see what are they. One is 1 to 2. So this one, then 2 to 5, this one, and 5 to 6, this one. Critical path is 0. Now you can see that for all the events in the critical path, the boxes are same. The values in the boxes are same, and the length of the critical path will be given in the boxes in the final, the last one, for the last node. What is in the final of any of these boxes, that will give you the length of the critical path. So this is an easy way to find out the means length of the critical path. Even in the forward pass itself, you will get the critical path. Now I have explained it on basis of a symbol diagram. It's a symbol network, but that may not be the case which was asked to you, because if for a symbol case, I have already explained you. If there are only 4 or 5 ways to 5 paths, then you can find out what is the total length of all the paths and find out the critical path. But otherwise, if it is a lengthy procedure, you have to follow this rule, and then only you will get the exact critical path.